All right, so I have the two questions you sent me on my smart notebook, so we'll just go through them one by one. This is the first one. I think you just want me to graph this. So I'll do this first equation in red, and I'll do the second one in blue. So basically, when you see these x is greater than or equal to 0 and y is greater than or equal to 0, when you have your coordinate plane, there should normally be a cross here, but this means x has to be positive and y has to be positive, so that puts us in the first quadrant. So as soon as you see that, you can just draw your axes like so. Okay, so the first thing I want to do with each of these is find intercepts. So I want to find the intercepts here. That's the easiest way to graph them if you have the x and y on the same side. So the first thing I'll do is I'll find the y-intercept by letting x be 0. So I'm going to figure out what does y equal when x is 0. So I can just cover this up, and I'm left with 2y. When we're graphing with intercepts, we don't need to include the inequality. So we'll say 2y is equal to 10. That only matters when we're shading. So then when x is 0, I get y is 5. So that's going to give me the point 0, 5. Okay, and I'm going to do the same thing but reverse. I'm going to let y be 0 and then solve for x. Notice this term goes away because the y is 0, and I'm just left with x equals 10. So then I get 10, 0, and 0, 5. So I'm just going to eyeball this right now. 10, 0, I'll put somewhere right here. If they have a graph, obviously there, it's much easier to graph this. And then 0, 5 about halfway up. Half the distance of that. This is going to be 0, 5. Okay, and now I'll do the same thing. Well, I'm going to connect them with a solid line. So let me make that red. Because it's solid, because it's greater than or equal to. And then I have to determine which side to shade. So I'm going to always use 0, 0 as a test point. It's just the most convenient. You can use any point you want, but it's just the most convenient. So if I plug 0 in for both of them, I get 0 plus 0 is greater than or equal to 10. That doesn't make sense. That's not a true statement. This is false. So that means this is the wrong side to shade. So I'm going to shade above this line when I'm ready to start shading. I'm just going to do this right now just to know, to remind myself that I have to shade above this line. Okay, now I'll do the same thing for the second line. I'll do that one in blue. Intercepts, I'll let x be 0. And then you'll see when x is 0, this goes away. I'm just left with y equals 8. And then I'll let y be 0. You'll see when the y goes away, the x is just going to be 8. So I'm going to connect those 2 points. 8, 0. So somewhere, if this is 10, 8 will be somewhere right about here. And then if this is 5, 8 will be somewhere right about here. Again, connect them with a solid line because it's greater than or equal to. And then I'm going to test 0, 0. If I plug 0 in for x, 0 in for y, I get 0 is greater than or equal to 8. Again, this is false. So I'm going to shade above the blue line. So now it's just a matter of finding the overlap of both of those lines. Notice it's everything above the red and above the blue. So it's going to be my region right here. Okay, that's that one. Now I'm going to show you the second one. This is a linear programming problem. It's going to be the same thing, but a couple extra steps. So let me start by adding my coordinate plane here. Y, X. Okay, so the first line I'll do, we'll make this orange. So the process is the same. I'm going to let x be 0 and solve for y. So if I let this be 0, that's going to go away. I'm left with 7y equals 42, or y equals 6. Now the reverse. Let y be 0. Cover this up. I'm left with 2x equals 42, or x equals 21. So I'm going to graph 0, 6 and 21, 0. 21, 0 I'll put out really far here. And 0, 6, I don't know, somewhere right about there. They're going to be connected with a solid line because it's less than or equal to. Let me do that again. Okay. So then we would attach 0, 0. If I plug 0 in for x, 0 in for y, I get 0 plus 0 is less than 42. So that's a true statement. So when I shade, I'm going to shade towards 0, 0. I'll wait till the end to shade. Second line, we'll do purple. Same thing here. I'm going to let x be 0. When x is 0, I get 3y equals 40. Divide by 3, you get what? 13.33333. 13.3. So we'll just say 13.3. Okay, and then I'm going to let y be 0. I get 4x equals 40 or x equals 10. So then I have the point 10, a little less than halfway here. Times 0. And then 13 would be a little higher than double that. This would be 0, 13.3. Again, we're going to connect those with a solid line because it's less than or equal to. Okay, and then test 0, 0. 0 plus 0 is less than 40, a true statement again. So I'm going to shade towards the origin. So there's my shading. So then when I look at the overlap, it's everything below the orange and to the left of the purple. So it's going to be this quadrilateral thing right here. Okay, so I have 4 vertices. I have 0, 6, 10, 0, 0, 0. But if we're maximizing this, the answer is very, very rarely ever going to be 0, 0. And then I have this point right here, which I have to figure out what that is. Okay, so that's the same thing as finding out where these two lines cross. Okay, so I'm just going to rewrite them as lines, not inequalities, as equations. So 2x plus 7y is equal to 42. And 4x plus 3y is equal to 40. Okay, now I'm going to solve this using elimination. Okay, I'll multiply the first equation by -2. This way I'll have matching opposite coefficients here. I'm just going to rewrite this equation below so I can add them. So this is going to give me -2 times 2x is -4x. That's what I want. Same but opposite. -2 times 7 is -14y. -2 times 42 is -84. So now I can add these two equations together, and by doing so, the x's go away. So this crosses out with that. I'm left with 3y and -14y is -11y. And 40 minus 84 is -44. Dividing by -11, we get y equals +4. So that's a nice number. So the y value here is 4. To get the x value, you're going to take that y value and stick it back into either equation. I'll stick it into the second one. 4x plus 3 times 4 is 40. 4x plus 12 is 40. 4x, I'm going to subtract 12 from both sides, 28. So I get x equals 7. So this is the point 7, 4. Now the very last step is just to take these 4 vertices, these 4 corners of my box, and plug them into z here. So if I do 0, 6, I get z equals 3 times 0 plus 4 times 6, that's 24. Looking for the biggest. 0, 0, we know it's not going to be it. That's just going to give me 0. 10, 0. I get 3 times 10 plus 0 times 4 is 30. And then 7 comma 4 gives me 21 plus 16 equals 37. So this is the maximum value. So the max occurs when x equals 7 and y equals 4. I know it's a lot. It is an awful lot. But a lot of the questions, they already give you the region. You just have to plug in the vertices. But this is doing everything in one problem.